Why do ancient Egyptian numerals resemble nature? Counting methods of the primitive people brought about not only the rise of ancient civilizations but also the development of land surveying and calculation. The four cradles of the ancient civilizations are the Nile River Basin in Egypt, Tigris and Euphrates River Basins in Mesopotamia, Indus River Basin in India, and Yellow River Basin in China. All of these ancient civilizations arise along the rivers. Why was this the case? This is because humans require water to live in harmony with animals and plants. Land surveying refers to the techniques for measuring the area of land precisely. With the gradual development of the civilizations, people began to take care of their land. We may say that measurement was created in this process to distinguish their land from that of others. Calculation, on the other hand, refers to the literal skills in doing calculations. Primitive people developed the ability to calculate in order to live a more convenient life, which led to the birth of land surveying and calculation techniques. Ancient people paid attention to the sky that changed at regular intervals and tried to discover the rules of nature hidden in the skies. Find a place in the area that you live in without artificial lights and look up at the sky. You will see that countless stars twinkle and the moon change its shape every day. Not only the night sky but also the sky during the day changes all year around. The sky looks close in spring and summer, while it looks farther away in autumn and winter. They observed the changes in nature and tried to find rules in nature, such as how many days it takes for the full moon to appear and how many months it takes for the sky move closer and farther. Human life is closely related to the natural environment, and progress is possible through observation and experience of nature. This resulted in a massive influence of the natural environment on the development of mathematics. Ancient Egypt had a hot climate throughout the year. Due to the small rainfall, there was much desert in the area. Running through the center of Egypt was the Nile River that originated from Lake Victoria. The thing was, there was a massive flood in the downstream regions of the Nile every year. The flood carried the rich soil upstream and enriched the soil in the areas down the river. This is why people say, the civilization of ancient Egypt is the gift of the Nile. However, this phenomenon was not always a blessing. The floods destroyed the boundaries between lands and ruined all the crops that had been planted. People even fought one another after the flood, insisting that the other's land was theirs. The king of Egypt was troubled by the fights among his people and had his subjects try to find solutions. This resulted in the large-scale land survey project in Egypt to help the people to reclaim their land. The pictorial numerals used in ancient Egypt before 3400 BCE were organized in simple groups, making it useful in explaining mathematical principles. The ancient Egyptians used hieroglyphics that resembled figure in nature. The 7 hieroglyphics for 1, 10, 100, 1000, 10,000, 100,000, and million were represented by a staff, a heel bone, a coil of rope, a lotus flower, a pointing finger, a tadpole, and a man, respectively. We can see from these symbols that the pictorial numbers are not complex or difficult. If we had a string or rubber band around us, we could exactly replicate the hieroglyphics used by the ancient Egyptians. Trying to use our bodies to express the hieroglyphics and trying to guess what it represents could even be a fun game to play with friends. The ancient Egyptians represented numbers using hieroglyphics that were simple enough to be expressed with the human body. Then, why were there only numbers related to 10, such as 10, 100, and 1000? Why were there expressions for other numbers? The numbers represented as hieroglyphics were based on 10. The ancient Egyptians made symbols for numbers that can be expressed in powers of 10. By repeating these symbols, they could represent larger and more complicated numbers. Today, this numeral notation is called the decimal system. The terminology decimal system may be a little difficult for children to comprehend. However, the Egyptian numeral notation is convenient to understand and make use of numbers. This is because we just need to repeat the symbols to represent bigger numbers. How the numbers in hieroglyphics were created is extremely interesting. The symbol representing the number 1 takes the form of a staff, which was the most suitable. The heel bone represents 10. Scholars think it originates from a string to bind 10 sticks together or the shape of the heel bone. The symbol representing 100 was made to resemble a coil of rope. The symbol expressing 1000 is the shape of a lotus flower in the water. The symbol representing 10,000 means a pointing finger. It means a big finger. The symbol standing for 100,000 expresses a swarm of countless tadpoles. While the symbol for million takes the shape of a man lifting both hands up to worship the god or to see numerous stars shining in the night sky, and indicates the number that is surprisingly large, 1 million. With a close look, we can see that the hieroglyphics all resemble the forms of nature. What do these hieroglyphics look like to you? Doesn't the symbol for 100 remind you of the steam rising from a mug of hot chocolate? Doesn't the symbol for 100,000 look like a small larva living inside of chestnuts harvested in the fall? It would be also very interesting to think of yourself as an ancient person and try to make hieroglyphics representing different numbers. The ancient Egyptians did not use hieroglyphics just for numbers. It is said that there were originally about 750 hieroglyphics characters, which continued to develop within this framework. When we compare the hieroglyphics with the English alphabet that consists of A, B, C, D, E, etc., the number of letters in the hieroglyphics was much greater, making its use more difficult. The way ancient Egyptians expressed numbers was extremely simple. However, these numbers needed the same symbols to be written down repeatedly, which made their use very cumbersome. That is, the bigger the number, the more repetition of hieroglyphics. Other than this problem, ancient Egyptian numerals were simple in principle and relatively easy to use. The biggest limitation in the ancient Egyptian way of expressing numbers was that a new symbol needed to be created whenever a new number greater than before appeared. When the Roman general Julius Caesar invaded Egypt with nearly 1 million Roman troops, the Egyptian soldier who had to report the number of the troops on papyrus with hieroglyphs to his general may have been faced with a major challenge. Imagine the number of hieroglyphics that would have been necessary to express 999,999 Roman soldiers in Egyptian numerals. Starting with 1 million Roman soldiers, it would have been necessary to record how many Egyptian soldiers participated in battles, how many enemies had been killed or survived using hieroglyphics. Imagine how much of a headache that would have caused for the Roman general. If we had to use ancient Egyptian numerals, made up of hieroglyphics made up of pictures, in the field of science that uses large numbers, we would have to constantly come up with new symbols. Creating new hieroglyphics is never easy. This is why people tried to find a new way to represent numbers easily instead of making new hieroglyphics every time. As a result, today's numeral system of numbers, which increases the place values by the units of 10, was created. We can see how convenient this numeral notation is compared to the Egyptian numeral notation. If such method of expressing numbers had never been invented and we had to use hieroglyphics like in ancient Egypt, our mathematics textbooks would have been extremely thick, and we would have been spent most of the times drawing hieroglyphics during mathematics exams. How did the ancient numerals know the secrets of the skies? The Mayan civilization is known to have flourished in southeast Mexico and Central America, Guatemala, and Yucatan Peninsula more than 2,000 years ago. The Mayan civilization is one of the most famous civilizations to have existed. Mayans created the number 0, were so brilliant mathematically that they invented the calendar we use today, and built numerous works of architecture. Their civilization was a theocratic rule that worshipped the sun and the moon. Theocracy means that they had a rule by God. Simply put, the Mayans worshipped the sun and the moon as gods. Records show that they led an agricultural way of living. They also were extremely talented at astronomy. Astronomy is a study of the stars and the moon in the skies and the universe. The stars were not the only subject of study for the Mayans, who were deeply interested in astronomy. The temples or towers built by the Mayans may appear to have religious characters, but they actually served as observatories to explore stars and the universe. The Mayans were capable of architecture based on mathematical thinking, and their heightened interest in astronomy meant that they built observatories to study astronomy professionally. Further, the Mayans have made outstanding achievements in not only astronomy but also in mathematics. Their idea that the size of the number varies with the number's place value is the same as the numeral principle that we use today. Also, as mentioned earlier, 0 that some claim to have been invented in India was actually discovered by the Mayans first. It is surprising that the Mayans used 0, which was not used in Rome or Egypt at that time. Dresden Codex, the records that were kept by the Mayans, documented their discovery of 0. Dresden Codex contains accounts of astronomy, which the Mayans were most interested in, and predictions on when and how much rain would come in relation to agriculture. It also contains stories of the daily lives of Mayans, who were farmers, and ends with a prophecy predicting the end of the world. The noble class Mayan monks made 20 symbols including 0 to represent numbers. The number of images that the Mayans used was not as many as those in the Egyptian hieroglyphics. A close look at the Mayan numbers shows that the location of numerals represents different values. As we can see in the picture above, Mayans used different symbols to represent the numbers from 0 to 19. It may look like there are too many numbers, but they are not so complicated compared to Egyptian hieroglyphics. We can see in the numbers above that all numbers but 0 expressed using the dots and lines. 1 to 4 dots express 1 to 4, and each horizontal or vertical line adds 5 to the value. Simply put, 1 dot is equal to 1, and 1 line is equal to 5. For example, 7 is expressed as 2 dots above a line, and 2 lines meant 10, a line is 5, and 2 lines indicate 5 plus 5 equals 10. Numbers over 20 was expressed by stacking up the numerals vertically. Because the Mayans used a vigesimal system based on 20 different symbols, numbers greater than 20 were expressed by stacking it up like bunk beds. If there are symbols made up of dots and lines on the first stack, as well as the second stack, it is safe to say that this number is larger than 20. To express numbers made up of 2 stacks, the number of the basic unit was on the bottom, and the number above 20 was on the second stack. Thus 23 is expressed as in figure 1 while 59 is expressed as figure 2. To explain figure 1 in more detail, the dot on upper level marked as 1 is multiplied by 20 since it is on the second level. This is added to 3 on the bottom, making the number 23. This is how the Mayan numerals were like double bunk beds. Figure 2 works similarly. The 2 on upper bunk is multiplied by 20 and is added to 19 on the lower level, which sums up to 59. As such, the Mayans expressed all the numbers with only 20 symbols, and value of the number differed depending on where the symbols were located. This is similar to how we express numbers today with just 10 numerals: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, where the value of the numbers changes depending on their location. The Mayan numerals are convenient in that we only need to know 3 things to recognize 20 numerical symbols: a dot as a representation of 1, a line as a representation of 5, and the symbol for 0. An important thing to note is that the Mayans calculated from top to bottom. For example, today when we think of the number 100, we call the third place from the right the hundreds place. Any numerals on a hundreds place are a multiple of 100, such as 100, 200, and 300. The Mayan method of calculation was quite different. When Mayans put numerals on the third row, it was a multiple of 400, as the place value increased each time 20 was filled, and 20 times 20 equals 400. However, when they used numbers on a calendar, the third row represented a multiple of 360, not 400. To the Mayans, who used a solar calendar called Hab, a month had 20 days, a year had 18 months and 5 days, which was a total of 365 days. The remainder of 5 from the division by 20 was thought to mean bad luck. This was why the Mayans used a multiple of 360 on the third row when calculating numbers. Let us look at the picture on the left. The number on the left is 13 times 360, plus 2 times 20, plus 19, not 13 times 20 times 20, plus 2 times 20, plus 19, equals 13 times 400, plus 2 times 20, plus 19. Simply put, the number on the second bunk is multiplied by 20, and the one on the third, top, bunk is multiplied by 360. Let us look at the figure more closely. The number 13 on the third bunk is multiplied by 360. 2 on the second bunk is multiplied by 20, and the 2 numbers are added by 19 on the bottom bunk. In the end, we we get 13 times 360, plus 2 times 20, plus 19. Then why was 360 used rather than any other number? This was because of the way Mayans thought, given their ability to make and use calendars. On the calendar, the third level represented the years, and a Mayan year constituted of 360 days. However, the following level returns to an increase in place value by 20. That is, the fourth row in on are 20 times bigger than the previous row. The third row does not follow the regular pattern, so 1 on the fourth row is 7,200 equals 20 times 360, not 8,000 equals 20 times 20 times 20. It follows that the fifth row is a multiple of 144,000 equals 20 times 7,200, not a multiple of 160,000 equals 20 times 20 times 20 times 20. Let us go back to the analogy of the bunk bed to help with our understanding. The second bunk is multiplied by 20, and the third bunk is multiplied by 360. The third bunk is the only one that is multiplied by 360, and all bunks above it are multiplied one more time by 20, with the fourth bunk being multiplied by 360 and 20, and the fifth level multiplied by 360, 20, and another 20. Likewise, regardless of how big the number is, the Mayan numeral system is easy to understand if we just calculate each level one by one, rather than trying to skip levels. Why were ancient Babylonians such good merchants? Let us talk about the numerical system made by the Babylonians. 4,000 years ago, King Hammurabi ruled Babylonia. The numerical system used at the time is called the Babylonian numerals. To better understand the Babylonian number system, let us look at the numerical system used by the Sumerians. 5,000 years ago, Sumerians started to farm and domesticate animals. They also started to express numbers and letters using writing tools. The letters used by the Sumerians are called cuneiform, which means wedge-shaped. The Babylonians adopted and developed the Sumerian numerals, which were written in cuneiform. When the Sumerians first created numbers, they neither got help from nor imitated the Egyptians. This meant that Sumerian numerals were much more complicated compared to the ancient Egyptian hieroglyphics. The following is a picture of clay tokens made by Sumerians to represent different numbers. The shapes above may look similar to one another in our eyes. Still, if we were to remember the shapes and the numbers they represent, expressing various numbers is rather easy. Sumerians overlap shapes to express numbers, unlike the Egyptians who repeated the same shape. In other words, the Sumerians combined two shapes into one to express a number. Then now, how did Sumerians draw the shape of the tokens into figures? As we can see in the picture above, 600 was represented by a small circle that means 10 placed on top of a larger shape that means 60. That is, 600 is a combination of a token that means 60 and the token that means 10. Once we know such methods of numerical expressions, we can express whatever number we want. Let us look at another example, 36,000. 36,000 is written by combining the larger circle which means 3,600 with a small circle that represents 10. It will soon become apparent that this method of expressing numbers decreases the number of symbols we need to learn to express numbers. If there is a number we wish to express, we simply need to overlap different symbols together and create a new shape. There was no need to make new numeral symbols. Still, this method was somewhat inconvenient in that people needed to do some calculations to read and write bigger numbers, as a bigger number required more shapes to be overlapped on top of each other. Then what would a relatively bigger number, such as 3,600,000, look like in Sumerian numerals? The early Sumerian numbers did not use the concept of place-valued system. This way of expressing numbers is similar to Egyptian numbers in that it was a series of additions. Also, like Egyptian numbers, Sumerian numbers grouped the same units together. For example, 4,980 equals 3,600 plus 600 plus 600 plus 60 plus 60 plus 60, so it is expressed as shown in the picture above. For bigger numbers, multiple symbols needed to be used. What would 9,960 look like in Sumerian numbers? If mental calculations are difficult, we may want to try drawing it out on a piece of paper. The bigger the number, the more symbols we will need to use. Converting the Sumerian numbers to the Arabic numbers will also take more time. Sumerian numbers use a sexagesimal number system. Sexagesimal 60 is its base, so the place value goes up by a multiple of 60. Today, the sexagesimal numeral system continues to be used to measure angles, time, and moon cycles. The ancient Egyptians used a decimal system while Mayans used a vigesimal system. However, the Sumerian sexagesimal numeral system did have problems. When they were expressing large numbers that were not multiples of 60, they had to repeat the same symbol endlessly. To solve this problem, Sumerians made a symbol for subtraction. Using this symbol, 59 could be written as 60 minus 1, as seen in the previous picture. To express 59 with the early Sumerian numeral system required 14 symbols, the new method only needed 3 numerical symbols. Just as the world we live in goes through constant progress, Sumerians were also looking for ways to more conveniently express numbers rather than settling for their ways of life. In the process of simplifying the way to write numbers, such as 59, Sumerian expression of numbers underwent a major change. A new writing tool was invented. These wedges were stone or wooden tools that were carved to have pointed V-shape edges. Sumerians were able to carve out sharp lines with this tool, giving the letters the name cuneiform, which means wedge-shaped. Our thought upon seeing these writing tools may be, there was no ink, so it did not write on paper, but it was sharp, so it must have been used somehow. The sharp edges were used to write cuneiform on clay tablets. As time passed, the Sumerians also carved letters into metal plates.